This is my oscilloscope. I've had it for a couple of years now. It's been great. It does everything I need it to do. It's invaluable doing troubleshooting or breadboarding. It's lightweight, doesn't take up much space. You can see it lives on just this narrow little shelf here. There's just one problem with this oscilloscope, and that is it does sit on this shelf here above my electronics workbench, which is on the upper floor of my house. And my DIY synthesizer lives in the basement of my house. If I'm down here and I want to take a look at a waveform, what do? Well, I could go up 2 flights of stairs and unplug the oscilloscope and gather up the power cord and the probes and pick up the oscilloscope and carry it down 2 flights of stairs and put it here and plug it in and connect up the cables and look at my waveform and disconnect the cables and unplug the oscilloscope and carry it back up 2 flights of stairs and put it back on its shelf and plug it back in and come back down 2 flights of stairs and suddenly realize there was something else I wanted to look at. Or I could use this. So a couple years ago, somebody on the LMNC discourse group was offering up for sale a DSO138 kit, which they had bought and then decided not to use. The DSO138 is an oscilloscope. It was made by a company called JYE Tech, and it's a very, very basic oscilloscope. It's got only 1 channel, doesn't have a lot of functions. It comes with no power supply. You have to come up with your own 9-volt power supply to run it. It doesn't have a case. It's just 2 printed circuit boards. One has the LED display mounted on it, and that plugs into the other circuit board, which has the rest of the circuitry on it. And it comes as a kit. You have to put it together. The main circuit board has some surface mount parts soldered to it, but otherwise, you've got a bunch of through-hole parts that you need to solder and put it all together. But it works, and it works pretty well, and it is ridiculously cheap. It's like about $35 to buy one of these things. There also are some companies that make knockoffs or counterfeits of the DSO138, which can be bought for even lower prices if you're into that sort of thing. So I decided I wanted to get this thing and build it, but not as a handheld scope as it was designed to be, but as a synthesizer module. Now, this has been done before, something like this. If you go to the AI Synthesis webpage, there's instructions there for basically taking a DSO138 and screwing it to the rails on a Eurorack synthesizer, and they add a 3.5mm input jack for patch cords, and they add a Eurorack header with a 9-volt regulator to supply power to it. It's kind of rustic, but it works. There's some other projects I've seen that make it look a little bit fancier. There's a couple I've seen on Reddit. One has a 3D printed front panel. This is another one, and this one is, I'm pretty sure, based not on the DSO138, but on its successor, the DSO138 Mini. The original DSO138 is no longer in production, although you can still buy it. And then here's another one. There's a YouTube video. I've got links in the description below for most of these things. And yeah, various people have done this with Eurorack. I don't know of anybody who's done a Kosmo version before me, so I decided it was up to me to try to do it. So I decided to take a somewhat different approach than AI synthesis or this one on Reddit, where they used the scope pretty much as designed and then mounted it somehow parallel to the front of the synthesizer. And I didn't like that because it means that you have to have a module that's like at least 12 centimeters wide, and that struck me as too wide to really justify for what it gives you. Yeah, this is me complaining about the width of the Eurorack module and how it's too wide for my Kosmo synthesizer. Shut up, okay? It really is. The horizontal form factor of this thing is not really compatible with a vertical format of a synthesizer module. So what I decided to do was to mount the display behind the front panel, parallel to it, but the main circuit board is mounted perpendicular to the display. It's also turned 90 degrees, so it's not quite as enormous a depth as it otherwise would be. And there's this 40 conductor ribbon cable connecting the two rather than having it plugged directly in. So that gives you a panel that's only 10 centimeters wide, not too bad. And however, the main circuit board has mounted on it several tactile push-button switches and some slide switches and an indicator LED and a BNC jack for the input, all of which you want to have on the front panel. And so what I did was I designed an auxiliary circuit board that mounts on the front panel and to which are mounted the tactile switches, the slide switches, the indicator LED. There's a BNC jack on that front panel that connects to the auxiliary board and from there to the main board. But there's also a 1/4-inch phone jack, and there's a toggle switch that lets you select which of these you're going to use for the input. If you're using this, then this signal is buffered and it's sent back to this output jack. So that means you can, if you have a patch, you can take one of the cables and pull it out, plug it into here, plug a cable from here back to where the other cable was originally going, and then you've just inserted this within the patch without disturbing the patch. All these switches and the LEDs and so forth are connected to the main circuit board with these ribbon cables that plug in here, and they're soldered to the main circuit board on the footprints where these switches and so forth normally would go. On the auxiliary circuit board, there's also a Eurorack type power header, and there's a 9-volt regulator there, which supplies the 9-volt power to the main circuit board via those wires there. One other thing that's on the front panel here is a switch labeled power, and that just interrupts the 9-volt power going to the main circuit board. And there's a couple reasons you might want to do that. One is that the oscilloscope draws about 120 milliamps of current, not a non-trivial amount of current, and, you know, why stress your power supply with that if you're not actually using the scope? Another thing is the LED, as I understand it, these LED displays have a sort of a finite lifetime, and the longer you run them, the closer they are to stopping working. So if you have it turned off when you're not actually using it, presumably that helps extend the life of the LED. And then finally, this is a digital circuit, and it's putting who knows what kind of digital noise out on the power rails when you're using it. So probably nice to have it turned off when you're actually trying to make some good music. So if this is something of interest to you, and you think you'd like to build one of these, as I said, the DSO138 is out of production, but you can still buy them. And there's links in the description below for the Git repository where you'll find the schematics and design files for the auxiliary board and the front panel to find the STL file for this bracket, and build notes about how it all goes together. And also, if you would like to, there's one set of the auxiliary circuit board and the front panel available for sale on my website as of right now. If that's still available, there will be a link in the description below. You can go there and buy yourself one. And hope you enjoy it. Hope you have fun with it. If you come up with some interesting variations on it, let me know. And I will see you next time on Analog Output.